Thanks, Lydia. That's awesome. So today I'm going to be talking about frameworks. And I want to talk specifically about JavaScript frameworks, which, if you're not familiar with them, are actually very similar to JavaScript frameworks. And a lot of the same issues are going to apply in between the two ecosystems. And the specific thing I want to dig into about JavaScript frameworks is, why are there so many of them? What is going on? What are you guys doing? This is something I really wanted to understand. And so I dug into it. This is a journey that happens at the beginning of every project that I start and the beginning of every project that most of you start, which is, we're looking to build something specifically in the browser, specifically with JavaScript. What framework should we use? And this is normally an exercise of looking out and evaluating the 10 or 20 million frameworks that have been invented since last time you created a JavaScript project, and finding that there is absolutely no community consensus about which one is the appropriate solution for the problem that you're trying to solve. And in the JavaScript community, this is kind of considered to just be a normal thing, like that's just kind of the way it is. But in other communities, in other programming languages, this is not considered normal, and it's definitely not considered good. If you're, say, writing Swift or Objective-C, you're using Cocoa. You're using Apple's framework that they provide, and it's not perfect, but it's actually really good. It's already installed in the operating system, and there it is. It's what you're going to use. If you're using Ruby, you're probably looking at Rails. There's lots of other options, for specific use cases. But the sort of de facto thing that's driving a lot of Ruby applications is Rails. And it gets a lot of development. There's a lot of documentation. There's a lot of Stack Overflow answers. And people generally understand how to build things on Rails. If you're in the C++ world, it's even more extreme. You're probably only using C++ because you're using it for some particular framework, or you've already decided we're going to use Unreal because the Unreal Engine solves our problem, and therefore, I guess we're using C++. The JavaScript world, though, the JavaScript world has a lot of frameworks. A lot. And it's kind of mind-boggling. I mean, believe it or not, the latest and greatest JavaScript framework comes around every 16 minutes, which is a lot faster. I haven't measured the other ecosystems, but I think it's a lot faster. This comes from an important scientist. But in our community, it's so extreme that we actually have entire projects just dedicated to making this slightly less ridiculous. The Todo MVC Project is actually a really useful, really important project that's run by some very smart folks that help people put together examples of JavaScript MVC frameworks and what it looks like to build a to-do list application using these front-end JavaScript frameworks. So there's a few dozen up there. And in some other communities, they might think it's kind of weird that we're using the to-do list as the example for this, right? Like, I mean, isn't that kind of a trivial thing to be comparing the possibly most important architectural decision of your entire application by just comparing a to-do list? But believe it or not, a to-do list is actually the most sophisticated application you can build in a JavaScript framework before a new, cooler JavaScript framework comes along. So it's actually the perfect fit for this. So they were thinking really well when they made this to-do MVC thing. And but even though there's already dozens of frameworks on here, there's actually many, many more frameworks that people have created to solve really important, totally different problems that they want to get put onto this to-do MVC site, and they go through the pull request system. And if you go and look, I first was looking at this when I was kind of digging into this back in February. And at that time, the most recent framework that someone was trying to get added to do MVC, the pull request had come in a day or two prior, was for this thing called Riot.js. Which I had never heard of before. Apparently, when I was writing this article, I just sort of made fun of the fact that, oh, well, there's even just a new one someone tried to add yesterday, and apparently it's version 2 of Riot.js, and Riot.js is a 1 kilobyte version of React, which itself hasn't even hit 1.0, but Riot is 2.0, lol. And I thought that was really crazy, but I didn't have any idea of how crazy it was going to be, because when I posted that thing making fun of it, I got a whole bunch of emails like this. Thanks for the tip on that Riot.js thing. It's really cool. I'm going to use it for my next project. And I don't know. This really weirded me out, and I just didn't really fully understand how this was possible. How can it be that in an article, I can create this article entirely about how ridiculous it is that there's too many frameworks, and I get a bunch of emails saying, hey, thanks, cool, a new framework. The answer is JavaScript. That's how. This is something that's not, there's multiple frameworks in most languages. This particular mentality is very much just kind of part and parcel of the JavaScript community. And I think it's important and useful for us to kind of dig in and understand a little bit about what causes it, with the hope of maybe minimizing it in the future. So the defining thing about JavaScript, compared to any other programming language, is that it's the language of the browser. And that's, let's all be honest, that's really kind of what turned us on to JavaScript in the first place for most of us, right? Especially for client-side development. The browser is the most ubiquitous, the most successful, the most broadly distributed application software platform in history. It's kind of a big deal. And if you want to write something for the browser, which of course you do, virtually any software developer needs to, then you can have your software run on everything from a refrigerator to a wristwatch, and everything in between. And this is an incredibly, amazingly powerful thing. It's so powerful that it'll get people from all sorts of different backgrounds, technically, who were used to all sorts of different languages, all pulled into the world of JavaScript. And they just kind of get sucked into this vortex because it's not necessarily that they didn't like Go or PHP or Ruby, but it's that they needed to build things for the web, specifically for the client, for the browser. And what starts happening is you end up with this community that isn't really self-selected, right? It's not like a whole bunch of people necessarily. We started writing JavaScript, and then we are elected. We're into it enough that we're now at a JavaScript specific conference. But people who are first getting into it are normally just getting pulled in because they need to build things for the browser. And their backgrounds are often very technically diverse. And the frameworks that they were used to from their own platforms are like, oh, well, they were used to Rails, or they were used to whatever frameworks they have in Go, and all these various backgrounds, that educates what they're looking to do and how they're looking to do it in the world of JavaScript. So this creates a whole bunch of diversity in the sort of frameworks that people are creating and people are looking for. At the same time that we have this big diversity of how people are trying to do things, we have an even broader diversity of what people are trying to do. The web was originally created to just display static web pages, and a lot of people write JavaScript doing that to do. But a lot of it now is also creating web applications, rich productivity applications with a lot of interactivity that have extremely wide variance in requirements and situations that they're running in. Some of their consumer, some of their business, all the way down to people doing 3D graphics on the web, which is completely crazy, or at least we would have said is completely crazy even a couple years ago. And it's now actually becoming a plausible thing that people are really doing for serious projects. And so we have this incredible diversity of people from the technical backgrounds of how they're trying to do things, and also an incredible diversity of what people are trying to do in this language, which is really something remarkable. There's very little that you can compare it to that has such a diversity of inputs and outputs. And this generates a huge quantity of people who are trying to build their own frameworks, and a huge quantity of frameworks that people may be looking for. At the same time that we have this huge diversity of things, this huge, just unimaginably large amount of work that we may try to do on the web, we also have this very low base layer that the browser kind of gives us for free, specifically the language of JavaScript. For example, the standard library in JavaScript consists of a shitty date library and an empty can of tuna. That's all you get. And it hasn't stopped us. The web has completely revolutionized the entire world, right? But the way it's done that is by building all these layers on top of this. You might think that this would make people in the web community pessimistic, but it actually makes them incredibly optimistic and excited about the things that they can do on this platform, because they're given very little, but their goal is to accomplish just incredible things. And that is a good thing for a lot of reasons, but one of the consequences is this, which is the number of active repositories on GitHub. And of course, JavaScript is the arrow that's just going off the edge of the graph in the corner there. This is 350,000 repos, and I'm sure about 90 to 95% of those are JavaScript frameworks. So I'm not sure exactly if it will ever stop, but it's not like people are just doing this because they're bored, right? There is an incredible wide diversity of things that people are trying to do. And so it's actually generating a lot of work on the framework side. In the meantime, though, just because there's a lot of people trying to do a lot of things doesn't mean that we won't kind of settle on like, OK, finally, we have all the frameworks that we need. There's another force that, in addition to all these frameworks being created, is also killing frameworks. And that is also the browser. And what's happening with the browser is that it's moving incredibly, ridiculously fast. The browser is outdating frameworks far faster than on any platform that you would ever build a framework on. Compared to, say, when we talk about Rails, right? Rails has been around for many years now, and it's built on Ruby, and it was originally built on Ruby like 1.6 or something, and now it's up to Ruby 2.2. But the difference in between the platforms that framework was built on is really minimal. There's just not very much difference in between those. And so Rails kind of adapts to the foundation that it's built on, but there's not a lot of change there. Compare that to the browser, where there's been more changes in the browser probably in the last like 6 weeks than there's been in Ruby in that amount of time. Like maybe that's a little bit of exaggeration, but like it's just changing rapidly. So what ends up happening is that you have this really cool framework that's really good at working around the fact that the DOM is really slow. And man, aren't you really excited about how great that is? And then you have this framework built on the foundation of the browser, and then they maybe make the DOM not slow anymore. And then suddenly you have this framework that like doesn't really make sense anymore because it's built on something that's shifted. And this is a really common problem. This happens to frameworks all the time that have all the like weird legacy design decisions because then this is the way that IE6 handled things, and you do things this certain way. And IE6, like, it feels like a really long time ago, but it really wasn't that long ago when we talk about trying to build a big, complicated system and get it debugged and shipped. So the browser kills frameworks by getting better. And the other way that the browser kills frameworks and also undermines frameworks is by the simple fact of the entire kind of point of the web is that every single time somebody wants to use your application, then the browser downloads and parses the code in your application, right? I mean, that's kind of the point. That's what we want it to do. But that rule, the fact that that is what's going on when someone loads your client-side web application, means that all the code that's in your application that you're not making use of is now suddenly a liability. It's a performance concern. It's something you worry about, right? It's something that's potentially causing issues on some edge case that you're not even familiar with. And so this creates a sort of strong downward pressure on the maximum happy size of a JavaScript framework. That's not the case in other platforms. And this is actually really kind of problematic for someone who's trying to create the final JavaScript framework to end all JavaScript frameworks that solves everyone's problems for everything. Because the natural progress of a framework, once it does a little bit, is to start doing more. And it starts to do neighboring things. Once it solves this problem well, you have someone who's like, well, I have a similar problem, and then you build the framework so that it solves both problems. And in most worlds, that's a good thing. And that's generally what people who come from other platforms, and maybe come from like native app development or something, are often looking for. In 2008, I spent a couple of years actually building software in Sprout Core, which was one of these frameworks that was in this vanguard of finally Moore's Law has made it so we can make a JavaScript framework that will end all JavaScript frameworks. It will have all the UI libraries that we'll need. It's going to have all the various functionality that we expect from something like Cocoa on the Mac, and we're just going to build into the browser. And it was almost ready. It just needed a few little pieces of polish and a bit of documentation, and it was going to be great. And so this is in 2008, and there was a lot of optimism at that time. We were getting demos of things like Cappuccino and GWT and things like that. And we were building this really featureful app. It was a productivity app, so like Keynote, Pages, Numbers at Apple. And we were like, we're going to build this on the web, and it's going to be amazing. And it was okay. It was pretty good on the desktop once we worked through the various performance problems that we had. And then mobile happened. And that was kind of a problem, because we had multiple megabytes of JavaScript. And when I was given an iPad and said, oh, it needs to work on this, otherwise it'll be kind of embarrassing, it would crash as soon as it loaded, because it would blow the 256 megabytes of memory on the iPad. And that was really sad, and it made me really sad, because I had really bought into this idea that Moore's Law was just going to solve frameworks, and we would be able to make a framework that would solve all our problems, and you could build in all the same defaults and all the functionality, have a bunch of really smart people just give you a toolkit to be able to build software. And more and more, especially after this kind of downfall of this particular framework that I had fallen in love with, or at least gotten good at, I started to feel like this is maybe an evolutionary dead end. That maybe this thing that maybe seemed reasonable was actually kind of dumb. And when you looked at it, it's like, no, this seems, yeah, that could be a thing, but it just doesn't make sense to be a thing. And that's kind of sad, because I sort of wanted it to be a thing, because it's kind of awesome and weird. But what I've seen in the years since, that was almost 10 years ago now, like the Sprout Core and stuff like that, is that what happens instead in the client world and the browser framework world is that small, nimble frameworks tend to outcompete the large, growing frameworks. And to some degree, this is because of this performance problems of the more code you have, and if you have someone else's code that solves other problems you don't need, then that causes problems for your framework that you're using, and so you end up have this kind of sharding behavior. But there's also another effect, which is that it's kind of this small, nimble, more libraries than frameworks is kind of natural to the way that JavaScript likes to be written. It's a quirky, dynamic, loose language that, it's not typed, and you can have APIs like this. What does it do? I don't know. But it was really quick to write. And, in a small little library, as long as the person who's using it is the person who wrote it or someone who understands it pretty well, or this is like one of the core functions of it, it successfully loads whatever that loads. And that's OK. You don't need an IDE that can tab complete and tell you what all those parameters mean and make sure at compile time that you're not passing in one of these things and it needs to be something different. Of course, for a large application, when you start getting up to something the size of the Unreal Engine or an operating system, this starts to become really problematic. Not just the fact that you can write an API like this, but the fact that someone else does, that there's no way at typing time to know what's going on with this. And companies like Google and Microsoft that are used to dealing with giant code bases, no surprise, are getting more and more interested in how do we kind of give the IDE and give a bit more compiler sense for types and things like that into JavaScript. And to some degree, that will probably make it more tenable and easier to maintain large frameworks, as well as to actually build on, maybe more importantly, to build on large frameworks that have been built in these kind of languages. But it's a while out, and there's definitely a fair amount of unrest in the community that this takes away some of the fun of JavaScript. So instead, the general sort of consensus among the people who know what they're talking about, TM, is to build things with micro frameworks instead, right? We compose everything out of lots of little small things, which they call micro frameworks. I think they're just libraries. I don't really know why we're calling them micro frameworks, but apparently they're micro frameworks. And you compose your application out of all these little puzzle pieces. And this is actually a really great approach for building an application when you have really smart people who understand the ecosystem, they understand the tools that are available to them, and they understand the problem that they're trying to solve. And so they can actually go out, and you have people who often have themselves written their own frameworks, or at least libraries and things like that. And so they can go and they can download these micro frameworks, and they can read the source and figure out whether or not they're a good idea and compose this into a project for themselves. Unfortunately, for a team that's maybe not super strong yet at JavaScript development, or a team that doesn't necessarily focus on the client, or a team that's a mix of a number of junior developers and some senior developers, is that it ends up being more kind of just dumping a whole bunch of different puzzle boxes into a giant pile and then trying to pull pieces together and put together a puzzle. Right? It doesn't give them a coherent sense of this is how you should build JavaScript apps with this set of tools. It's just, yeah, well, fend for yourself, guys. And that's often not a tenable solution for a large company for a large project. And so instead, you get a CTO that's told, all right, pick a JavaScript framework. So they do this, little JavaScript frameworks. Of course, that returns garbage results that are all from 2014 and are completely useless now. And so they do this. And I know they do this because now what they get is the article I wrote in February 2015 saying that there's too many frameworks and they're screwed. And then they write me emails about Riot.js. So Is this bad behavior? Is this just people not being clueless? No. This is people who are trying to solve a problem. They need to have a coherent, teachable, readable set of documentation for their team about how are they going to try to solve the problems they have on one particular project. People don't want to spend their entire time evaluating whether or not Boron.js is a cool new way to solve this tiny part of the problem that they have. What they want to do is they want to jump on board with something and get where they're going. Right? And unfortunately, what this causes is whether they start with micro-frameworks or they start with some homegrown thing, use vanilla.js, don't have a framework, means basically what they do is that they end up creating a framework. And once they've created their own framework and they find the extreme cost of maintaining that framework and then they can't really hire anyone because no one outside the company knows the framework, someone has a great idea. What we're going to do is we're going to release our own framework into the world. And once we've done that, we will solve global warming once and for all. Once and for all. So now we're back where we started. So I think we have at least a much better understanding of why we have so many frameworks and why there's this continual churn. But before I finish, I want to touch on 4 ideas of maybe what we can do about it when we're in this situation, we're in this community, and how can we deal with it. Well, option number 1 is that we could actually start to enshrine some of the functionality that we have in these frameworks right into the browser. This is a slow process, and it means you need to get all the standards bodies and the browser vendors to agree that actually, yeah, we should have this part of this framework, or even, hell, a whole entire framework built right into the browser. So this is a hard problem, but there are some examples of this actually working. If you look at like query selector all, and in 2016, when all the browser vendors kill React because they just kind of build that in too, because all the frameworks are basically doing the same thing now. When that kind of stuff happens, you end up actually reducing the amount of complexity that the frameworks need to have, and you end up reducing the amount of thrash because it's like, well, we could replicate this functionality in the browser, but the way the browser does it is pretty good, so let's just go with that. Option number 2 is that we can get really low level. We can go right down to the level of some of these new frameworks that are not frameworks, but new APIs that are coming out, like WebGL, Asm.js, and now the WebAssembly stuff that's coming down the pipeline, hopefully, to be able to build on a stable bottom layer that's not going to change anymore. And once you start doing that, once you start building frameworks that end up going to WebAssembly, then what happens is that it's a standard platform that's not changing anymore, and so you can build up substantially larger amounts of complexity, and you can work around problems like not having certain features in JavaScript and things like that. Maybe we're not even using JavaScript anymore. So again, this is a relatively long-term solution, but it could actually be a fairly permanent one if we get to the point that things like WebAssembly and WebGL are like fully widely supported and they work on all the platforms that we want them to be on. Option number 3 is a little more feasible in the short term, and it's kind of what a lot of people are doing, which is this incremental breakage idea. Is that we create a framework, and even though it becomes popular, we resist the urge to make sure that we continue down that path, because in the web world, we're always finding new and better paths and new and better ways to build our software. And so we make the difficult decision and we say, well, yeah, I know a bunch of you really liked our bicycle, but now we're making a car. And so if you want to move to car, then you're going to have to come with us, and it's going to be a bit of work. And this is what Angular has been doing. People, including me, have given them a lot of crap for, in Angular 1, building the most hyped framework of all time, getting a whole bunch of people to build Angular 1 apps, and then Angular 2 being like, actually, Angular 1 stuff isn't going to work anymore. That's old and busted. We're doing a whole other thing. And the fact that they're willing to do that, it's pretty daring, and it risks all the momentum they have with Angular 1, but it's a different kind of risk than the risk of just slowly sliding into oblivion, along with the entire long history of other frameworks that made bad initial decisions and then eventually just sucked themselves out of life. So this incremental breakage thing actually might be the least bad path forward. Option number 4, though, is to embrace the chaos. Right? This is the web. It's always been chaotic. And maybe it always will be. And maybe, just maybe, that's what makes it great. Thanks.